Picture this scene and let it sink into your brain because what I am about to tell you sounds absolutely insane, but it actually happened, and it changed how American soldiers fought in the Pacific Theater. You were a Japanese soldier in 1944 defending a fortified position on some godforsaken island in the Pacific. You have spent weeks digging bunkers and reinforcing positions with logs and sandbags. You have survived naval bombardment and airstrikes, and you feel relatively safe behind your concrete and steel pillbox because nothing the American infantry carries can touch you in there. The standard American rifle fires a .30 caliber round that bounces off your fortifications like pebbles against a tank. You have seen it happen 100 times, and you know that as long as you stay behind cover, you are safe from small arms fire. And then something happens that changes everything. A sound unlike any rifle you have ever heard thunders across the battlefield. A sound so deep and powerful that it makes the ground tremble. And suddenly the concrete wall you are hiding behind explodes inward as a round the size of your thumb punches through like it was made of paper. Your bunker that was supposed to protect you has become your coffin. And somewhere out there an American Marine is operating what looks like a ridiculously oversized rifle. A weapon so massive that it takes 2 men to carry it. A weapon that Japanese soldiers came to call the monster gun because nothing else could describe the terror of facing something that made their fortifications completely useless. And the craziest part of this whole story is that this weapon exists because some brilliant American decided to take a gun designed for bomber aircraft and figure out how to put it in the hands of ground troops, creating one of the most devastating infantry weapons of World War II. To understand how the monster gun came to be, we need to go back to the problems that American forces faced in the Pacific Theater. And these problems were unlike anything they encountered in Europe. The Japanese military had spent years fortifying islands across the Pacific with elaborate bunker systems, pillboxes, and defensive positions that were specifically designed to resist everything the Americans could throw at them. These were not hastily dug foxholes, but engineered fortifications with reinforced concrete walls, interlocking fields of fire, and camouflage so effective that you could walk right past a machine gun nest without seeing it. The standard American infantry weapons of the time were designed for a different kind of war. The M1 Garand was an excellent battle rifle that gave American soldiers a huge advantage in firepower over bolt-action enemies. But its .30-06 round simply could not penetrate the kind of fortifications the Japanese had built. You could empty an entire clip into a pillbox and the guys inside would barely notice. It was like throwing rocks at a castle wall, and this meant that taking Japanese positions required either suicidal frontal assaults, flamethrowers that required getting dangerously close, or calling in air strikes and naval bombardment that were not always available. The frustration among Marine commanders was intense because they were watching good men die, trying to take positions that could have been neutralized with the right weapons, and this frustration led to some creative thinking about what kind of firepower could be brought to bear at the infantry level. The answer came from an unexpected source because while the ground forces were struggling with fortified positions, the Army Air Forces were flying aircraft equipped with absolutely devastating weapons. The bombers and fighters of the era carried machine guns and cannons that could tear through aircraft skin, engine blocks, and armored vehicles with ease. The most famous of these was the Browning M2, which fired a .50 caliber round that was originally designed as an anti-aircraft weapon in World War I, but had evolved into one of the most versatile heavy weapons ever created. This round was a monster compared to rifle ammunition, where a .30-06 round might weigh around 150 grains and travel at 2,800 feet per second. The .50 BMG weighed over 700 grains and traveled at nearly 3,000 feet per second. The energy difference was not just incremental, but exponential. And what some brilliant minds realized was that if they could figure out how to put this kind of firepower in the hands of individual soldiers, they could solve the bunker problem once and for all. The concept was simple, but the execution was incredibly challenging because the M2 Browning was designed as a mounted weapon for vehicles and aircraft. It was heavy, it had tremendous recoil, and it required a stable platform to operate effectively. You could not just hand this thing to a Marine and tell him to go hunting. The weapon system needed to be portable enough for infantry use while still delivering the devastating punch that made the .50 caliber round so effective. And this is where American engineering ingenuity really shined, because instead of starting from scratch, they looked at existing technology and figured out how to adapt it. The result was a series of weapons that took the principles of aircraft armament and packaged them into something that could be carried and operated by ground troops. And while the final products varied in design and implementation, they all shared the same basic purpose of giving infantry the ability to reach out and touch someone hiding behind fortifications that would stop any normal rifle round point. One of the most interesting developments was the adaptation of the M1 Garand operating system for larger caliber applications. The M1 Garand was already known for its reliability and its innovative gas-operated semi-automatic action, which allowed soldiers to fire 8 rounds as fast as they could pull the trigger. This was a huge advantage over bolt-action rifles, and the operating system was robust enough that engineers began experimenting with scaling it up for heavier ammunition. While the standard M1 Garand could not be converted to fire .50 caliber rounds due to obvious size and strength limitations, the principles it pioneered were applied to larger weapon systems that gave infantry devastating anti-material capability. The T-20 series of experimental rifles explored various automatic configurations of the Garand action. And other projects looked at how the same reliable mechanism could be applied to heavy weapons that individual soldiers could operate. But let us talk about what really made the Japanese call these weapons monster guns, because the nickname did not come from a weapon's appearance, but for what happened when these weapons were used in combat. Imagine being a Japanese soldier who has survived naval bombardment and airstrikes, only to face American infantry advancing toward your position. You have seen this before, and you know the drill. You wait until they get close, then you open up with machine guns from your fortified positions. The Americans take casualties and have to call in support or try a flank attack, or maybe bring up tanks if they have any. It is a deadly game, but one you understand. And then something new happens. The Americans stop advancing and instead set up what looks like an oversized rifle on a bipod, maybe 1,000 yards away, well out of effective range for your weapons. And before you can figure out what they're doing, the world explodes, not from artillery or airstrike, but from a single shot that punches through your concrete wall and kills 3 men behind it. The rifle round you just saw kill your comrades is still echoing across the battlefield as the Americans chamber another round and fire again. And suddenly you realize that everything you thought you knew about cover and concealment is wrong. Nowhere is safe anymore. The psychological impact of these weapons cannot be overstated, because they fundamentally changed the calculations that Japanese defenders had to make. Before the monster guns arrived, Japanese soldiers could trust that their fortifications would protect them from direct fire. They could pop up to fire at advancing Americans and duck back down, knowing that return fire could not hurt them through their bunker walls. But once the heavy rifles appeared, this calculation changed completely. Suddenly, the guy who pops up to fire might see a massive rifle pointed at his position, and if that rifle fires, the entire bunker becomes a death trap. The round does not just kill the person it hits, but sends concrete fragments and spalling through the enclosed space, turning the protective walls into weapons against their own defenders. Soldiers who had been confident and aggressive behind their fortifications became nervous and hesitant. They did not want to draw the attention of the monster guns. And this hesitation gave American forces opportunities they never had before. The Marines who operated these weapons became highly valued specialists because the skill required to effectively employ a heavy anti-material rifle was considerable. You were not just pointing and shooting like with a regular rifle. You had to understand ballistics at extreme ranges. You had to calculate for wind and elevation and temperature. You had to identify which targets were worth the precious heavy ammunition. And you had to be able to hit precisely, because unlike a machine gun that could spray an area, you were making single shots count. The men who excelled at this work developed reputations that spread through the ranks. Other Marines would specifically request their support when facing fortified positions, and the mere presence of a monster gun team could change the entire tactical situation. Japanese defenders who knew the heavy rifles were in the area would be more cautious, more willing to abandon exposed positions, more likely to make mistakes that cost them their lives. Now let us talk about the technical details of what made these weapons so devastating, because the physics involved are genuinely impressive. A standard rifle round relies on velocity and mass to deliver energy to the target. The .30-06 round used in the M1 Garand delivered around 2,500 foot-pounds of energy, which is plenty to kill an unprotected human, but not enough to penetrate serious fortifications. The .50 BMG round delivered over 13,000 foot-pounds of energy, which is 5 times more powerful. But energy alone does not tell the whole story, because the shape and construction of a round also matters. The .50 caliber armor-piercing rounds used by the monster guns were designed to maintain their integrity when striking hard targets. They would not deform or fragment on impact like hollow-point ammunition, but would punch through and keep going. This meant that a single round could penetrate a concrete wall, pass through whatever was behind it, and potentially exit the other side, still carrying lethal energy. The Japanese bunkers that were designed to stop rifle fire simply were not built to handle this kind of assault. The stories from the Pacific Theater about monster gun employment read like something from a war movie because the situations were so dramatic and the results were so decisive. There are accounts of Japanese machine gun positions that have been pinning down Marine advances for hours being silenced with just a handful of shots from a heavy rifle. The gunner would identify the position, set up at extreme range where Japanese weapons could not effectively respond, and methodically punch rounds through the fortification until the guns fell silent. There are stories of snipers using these weapons to engage targets at ranges that seemed impossible, picking off officers and equipment from distances where the sound of the shot arrived after the bullet had already done its work, and there are accounts of Japanese soldiers abandoning perfectly good defensive positions simply because they saw a monster gun team setting up. The terror these weapons inspired was worth as much as their actual destructive capability. The development of infantry anti-material rifles during World War II was not unique to American forces because several nations recognized the need for heavy weapons that could be operated by individual soldiers. The British had the Boys anti-tank rifle, which fired a .55 caliber round and was originally designed to penetrate light armor. The Soviets had the PTRD and PTRS rifles, which fired massive 14.5 mm rounds that could stop German armored vehicles, and the Germans themselves had various heavy weapons for infantry use. But what made the American approach different was the emphasis on precision and the integration of these weapons into combined arms tactics. The monster guns were not just handed to random soldiers, but were employed by trained specialists who understood how to maximize their effectiveness. And they were used in coordination with other weapons to create tactical situations where Japanese defenders had no good options. One of the most effective tactics that emerged was using the heavy rifles to create breaches that infantry could exploit. A monster gun team would set up at range and begin systematically engaging a fortified position, punching holes through walls, destroying firing ports, killing or suppressing defenders, and generally making life miserable for anyone inside. While the Japanese were dealing with this threat, American infantry would maneuver to positions where they could assault the weakened fortification. The defenders who were pinned down by the heavy rifle fire could not effectively engage the approaching infantry. And when the assault came, it was against a position that had already been partially destroyed and whose defenders were rattled and suppressed. This combined approach saved countless American lives and became a standard operating procedure when facing fortified Japanese positions. The ammunition for these weapons was another story of American industrial capability because the .50 BMG round was not simple to manufacture. Each round contained precisely measured propellant, a carefully machined bullet, and a primer that had to function reliably under all conditions. The armor-piercing variants required hardened steel cores that could withstand the impact forces without deforming, and the incendiary and explosive variants required even more complex manufacturing processes. American factories produced millions of these rounds during the war, keeping the heavy weapons supplied even as they were deployed across multiple theaters, and the quality control was impressive because a weapon that fires one shot at a time at extreme range cannot afford ammunition that varies in performance. Each round had to fly the same way and hit with the same power, or the precision that made these weapons so effective would be lost. Let me tell you about some of the specific weapons that earned the monster gun nickname, because there were actually several different designs that Japanese soldiers grouped together under this terrifying label. The most common was probably the M2 Browning deployed in ground roll, with specially designed mounts and optical sights. This weapon was typically vehicle-mounted, but could be set up on tripods for infantry use. Its rate of fire allowed for both precision single shots and suppressive fire when needed, and its range exceeded anything the Japanese infantry could respond with effectively. There were also purpose-built anti-tank rifles that had been adapted for anti-fortification work. These single-shot weapons were slower to operate, but extremely accurate and could be carried by two-man teams across terrain that vehicles could not navigate. And there were experimental weapons that never reached mass production, but were field-tested in the Pacific with terrifying results. The training required to effectively operate these weapons was substantial because you were not just learning to shoot, but learning to think like a long-range marksman. You had to understand how the bullet would behave at distances where standard rifle training did not apply. At extreme range, even small errors in range estimation or wind calculation would result in complete misses, and with ammunition that was heavy and relatively precious, you could not afford to waste shots finding your target. The Marines who specialized in heavy rifle work spent hours on the range learning their weapons and more hours studying ballistics and fieldcraft. They learned to read terrain for potential firing positions, to estimate range using various techniques, to identify high-value targets worth their limited ammunition, and to remain concealed while setting up and firing from positions that might be observed by the enemy. The recoil management of these weapons was another specialized skill because the energy that punched through concrete also pushed back against the shooter with tremendous force. The M2 Browning on a tripod mount could handle recoil through the weight and stability of the system, but lighter weapons required careful technique to control. The shooter had to position himself correctly, absorb the recoil through his body in a way that would not cause injury, and maintain his position for follow-up shots. Experienced operators developed a relationship with their weapons, understanding exactly how they would respond and how to control them. And this expertise made them far more effective than someone picking up a monster gun for the first time. The Japanese military attempted various countermeasures against the heavy rifles with limited success because the fundamental problem was one of physics. You could not make fortifications thick enough to stop .50 caliber rounds without making them so massive that construction became impractical. The Japanese tried using layered defenses with multiple walls, hoping that the bullet would expend its energy before reaching the defenders. They tried positioning machine gun nests in locations that were harder to engage from likely American approaches. They tried using camouflage more aggressively to hide their positions from the heavy rifle teams. But none of these measures fully solved the problem. The monster guns could be repositioned, their operators were skilled at identifying hidden targets, and even layered defenses eventually failed under sustained fire. The Japanese were facing a capability gap that could not be closed with the resources available to them in the Pacific. The influence of these weapons extended beyond their immediate tactical impact because they changed how both sides thought about fortification and firepower. Japanese engineers began designing positions that were less visible rather than more protected. Acknowledging that concealment offered better survival odds than armor that could not stop the heavy rounds, American planners began incorporating heavy rifle capability into their calculations for island assaults, ensuring that the weapon teams were available and properly positioned to support infantry advances. And the lessons learned about anti-material rifles influenced weapon development for decades after the war. The idea that individual soldiers could carry weapons capable of penetrating armor and fortifications became a standard part of military planning. The stories of individual monster gun operators deserve to be remembered because these were men who mastered a difficult weapon system and used it to save the lives of their fellow Marines. There are accounts of operators who engaged Japanese positions at ranges exceeding a mile, making shots that seemed impossible but were the result of skill developed through intensive training and practice. There are stories of men who held off Japanese counterattacks single-handedly, using the heavy rifle to destroy vehicles and fortify positions that would have overwhelmed normal infantry weapons. And there are tales of operators who died defending their weapons, knowing that if they fell, the monster gun would be lost and American advances would stall against fortifications that only they could crack. The psychological warfare aspect of the monster guns was deliberately cultivated by American forces because terror is a weapon too. When a heavy rifle team engaged a Japanese position, they were not just trying to destroy that specific target, but sending a message to every other Japanese soldier in the area. The message was simple and brutal. Your fortifications cannot protect you. Your bunkers are coffins, and there is nowhere you can hide that we cannot reach. This message spread through Japanese forces and contributed to a general decline in morale as the war progressed. Soldiers who had once been confident in their defensive positions became fatalistic, expecting death rather than hoping for survival. And this psychological erosion made Japanese forces less effective overall, even in positions that the monster guns had not directly engaged. The legacy of the monster guns lives on in modern anti-material rifles like the Barrett M82 and similar weapons that allow individual soldiers to engage targets at extreme range with devastating power. The concept pioneered in World War II has been refined and enhanced with modern materials and optics, but the basic principle remains the same. If you can hit it from far enough away with a big enough round, you could destroy things that seem invulnerable to normal weapons. Modern anti-material rifles can disable vehicles, destroy equipment, and neutralize fortified positions, just like their World War II ancestors. And the tactics developed by monster gun operators in the Pacific have been studied and adapted for contemporary warfare. The industrial story behind these weapons is also worth understanding, because creating effective heavy rifles was not just a matter of engineering, but of manufacturing capability. American factories had to produce weapons that could handle the tremendous forces involved, ammunition that was consistent enough for precision shooting, and optical systems that could survive the shock of firing while still providing accurate aiming. All of this required a level of industrial sophistication that most nations could not match. And it was this industrial base that allowed American forces to deploy monster guns in quantities that made a real difference in the Pacific campaign. The Japanese could not counter these weapons in part because they could not produce similar weapons or the ammunition to feed them at the scale needed. The training doctrine that evolved around heavy rifles influenced how the Marine Corps thought about specialized weapons in general. The idea that some weapons required dedicated specialists rather than general infantry training became more accepted, and this laid groundwork for the sniper programs and special operations capabilities that would develop in later decades. The monster gun operators were in some ways the ancestors of today's designated marksmen and sniper teams. Specialists who bring precision firepower to situations that require something more than regular infantry weapons can provide. The relationship between the operators and their weapons was often intense because these were not mass-produced rifles that could be easily replaced. Each monster gun had its own characteristics, its own quirks, and its own history. Operators learned their specific weapons intimately, understanding how they shot at different temperatures, how they responded to different ammunition lots, and how to maintain them under the brutal conditions of Pacific Island warfare. Losing a weapon was not just a logistical problem, but an emotional blow because the replacement would need to be learned all over again. And this relationship between man and machine contributed to the effectiveness of the weapon system. Let me talk about some specific engagements where the monster guns proved decisive, because these stories illustrate just how powerful these weapons were in the right hands and the right situations. During the assault on heavily fortified Japanese positions, the standard approach of artillery bombardment, followed by infantry assault, was proving costly. But when monster gun teams are deployed to engage specific defensive positions, the calculus changed completely. Operators would set up at ranges of 800 to 1,200 yards where Japanese weapons could not effectively respond. Then systematically engage fighting positions one by one. Each shot had the potential to penetrate concrete, kill defenders, and degrade the defensive capability of the position. After sustained fire from the heavy rifles, the infantry assault that followed faced reduced resistance and suffered fewer casualties. The Japanese reaction to monster guns evolved over time as commanders tried to find ways to counter the threat. Early in the war, Japanese positions were designed to resist naval gunfire and aerial bombardment without much thought to heavy rifle fire from ground troops. But as reports of monster gun effectiveness spread through the Japanese military, there were attempts to modify defensive doctrine. Some commanders ordered construction of fighting positions with indirect approaches that made them harder to engage from the front. Others tried positioning machine guns to cover the likely setups for monster gun teams. And there were even attempts to prioritize targeting monster gun operators with mortar fire and artillery. But these measures were largely unsuccessful because the heavy rifle teams were skilled at concealment and could often engage from unexpected directions. The ammunition logistics for monster guns were challenging because .50 caliber rounds were heavy and took up significant space. A soldier carrying standard rifle ammunition might have several hundred rounds available. But a monster gun operator was lucky to have a few dozen rounds of heavy ammunition. This scarcity meant that every shot had to count. Operators developed extraordinary patience, waiting for clear shots at high-value targets rather than engaging anything that moved. The discipline required was similar to what modern snipers practice, understanding that sometimes not shooting was more important than shooting, and that preserving ammunition for the right moment could be more valuable than expending it against marginal targets. The sound of a monster gun was distinctive enough that both American and Japanese forces learned to recognize it immediately. For Americans, it was reassuring, a sign that heavy firepower was available to support their advance. For Japanese, it was terrifying, a warning that fortified positions might not be as safe as they appeared. This auditory signature became part of the psychological warfare effect. Japanese soldiers who heard the deep boom of a heavy rifle would often take cover, even if they were not the target. And this suppressive effect added to the tactical value of the weapons. The maintenance requirements for monster guns were demanding because the forces involved in firing stressed every component of the weapon. Barrels wore out faster than on regular rifles. Actions required more frequent cleaning and lubrication, and optical sights needed constant verification to ensure accuracy. Operators became experts at maintaining their weapons, carrying specialized tools and spare parts, and knowing exactly what each component needed to function reliably. In the harsh conditions of Pacific Islands where sand, salt, and humidity attacked every piece of equipment, this maintenance expertise was essential. The evolution of heavy rifle tactics continued throughout the war as operators gained experience and shared lessons learned. Early employment sometimes put the weapons too close to enemy positions where they were vulnerable to counterfire. Later tactics emphasized maximum standoff distance, taking advantage of the weapon's extreme range to engage from positions that Japanese weapons simply could not reach. There were also developments in combined arms coordination, with heavy rifle teams working more closely with infantry, armor, and artillery to create tactical situations that maximize the weapon's effectiveness. The end of World War II did not end the monster gun concept, but transformed it. The anti-material rifle became a standard category of military weapon, with designs optimized for different roles and different target sets. The heavy rifles of World War II were replaced by purpose-built weapons that were lighter, more accurate, and more powerful, but the fundamental insight remained the same. There are times when infantry need the ability to destroy hard targets at range, and the weapons that provide this capability are worth their weight in saved lives. The veterans who operated monster guns often spoke about their experiences with a mixture of pride and soberness. They were proud of the skill they had developed and the lives they had saved, but they were also aware of the lives they had taken. Looking through a powerful optic at a man you're about to kill is different from the chaos of close combat. And the operators carried these memories with them. They had done necessary work in a brutal war, using a weapon that was remarkably effective at its intended purpose, and their legacy lives on in the anti-material rifles that modern militaries depend upon. The story of the monster guns is ultimately a story about problem-solving under pressure. American forces faced an enemy that had invested heavily in fortifications, and the standard weapons of the infantry could not crack those fortifications without unacceptable casualties. The solution came from looking at existing technology with fresh eyes, recognizing that aircraft weapons could be adapted for ground use, and developing the training and tactics to employ these adapted weapons effectively. This kind of innovative thinking characterized American military efforts throughout World War II and contributed significantly to eventual victory. Yes. You know why Japanese soldiers call them monster guns and why American Marines love having them on their side. These weapons took the devastating power of bomber aircraft armament and put it in the hands of ground troops, creating a capability that the Japanese simply could not counter. The fortifications that were supposed to protect defenders became death traps, and the men who mastered these heavy rifles became some of the most valuable specialists in the Pacific theater. The next time you see a modern anti-material rifle, remember that its ancestors were born in the island-hopping campaigns of World War II, where American ingenuity created weapons that could reach out and touch someone even when they thought they were completely safe. If you want to learn about another crazy weapon innovation from World War II, click on the video that is appearing on your screen right now, because the history of warfare is full of stories like this where desperate situations led to brilliant solutions.